Hello everyone, this is Muhammad Misbauddin. I am a student at University of British Columbia, working under Dr. Ilya Miskovich. In this video, I am going to talk about how the concept of oil and gas industry can benefit exploration and mining of minerals. Introducing the concept of digital rock analysis. It's one of the modern techniques used for visualizing the mineral spatial elements in a rock. Micro-CT, X-ray CT, scanning electron microscopy, and focused ion beam scanning electron microscopy are the most common tools which are used to scan the rock samples. SCM and FIB SCM are mostly used to capture the image on a nanoscale resolution. Here I am going to show you how the data from FIB SCM is collected. A mudstone sample is chosen for this study. Examining the sample under the resolution of 29 micrometers doesn't give any information. It's the same case with 2.5 micrometer resolution and also with 65 nanometers. A plug has been collected from this drill core and subjected to FIB SCM section analysis. Once you have your FIB SCM sample, you have a dataset which is a good representation and can be used for segmentation to calculate the mineral properties. Here I have chosen watershed segmentation to calculate average pore size and porosity of the sample. The main challenges of this method are the speeds of the data collection is very slow and the availability of the equipment is limited, and it is also very expensive method. Since the process of data collection is very slow and time consuming, why don't we introduce the concept of machine learning over here? We can take the image data from micro CT and we can feed it to our machine learning model, and another side we can take the calculated numerical data of FIB SCM and feed it to our machine learning model as an output, and we can train this using our CNN. CNNs are our machine learning models which are mostly used to train the image data set. Basically, we are skipping the whole process and we are predicting our results directly from micro CT data. A convolution neural network or CNN are a special kind of multi-layer neural networks designed to recognize the visual patterns directly from pixel images with minimal pre-processing. FIB SCM sample of a shale rock is analyzed in this study. To make our machine learning model more robust, a total of 16,000 images were extracted from this sample. Each image slice was of 512 by 512 resolution. The pores were identified using watershed segmentation. The images were converted to binary format to estimate its properties. Average pore radius and porosity were two properties calculated for this study. This is how the data was pre-processed for our machine learning model. A total 16,000 image slices were taken and they were segmented, and the properties, that is average pore size and porosity, were calculated for all 16,000 images, and these were used to feed our machine learning model. The 16,000 slices were sampled down to 32 by 32 resolution, that is almost to a micro CT resolution, and these were fed as an input to our convolution neural network model, and the data which was calculated from FIB SCM is fed as an output to our model. The image dataset for our machine learning model was split into 75:25 ratio for training and test set. That is, 12,000 slices were trained and the data was tested on 4,000 slices. The total training time was 4 hours and 15 minutes on a GPU machine with a batch size of 64 and 1000 epochs. These were the following results predicted from our machine learning model. The blue trend line here is the actual values calculated from FIB SCM slices, and the orange trend line is the predicted values from our machine learning model. There was an error of 0.3%, which is almost negligible. The results were also same for average pore radius. We got an error of 0.0035 nanometers on an average for each slice. In conclusion, I would like to say that the concept of digital rock analysis, which is widely used in petroleum world to visualize and model rock properties of multiple scales, is an excellent crossover concept for mining, which can be used to minimize the risk and improve the outcomes of an exploration program. The similar example can be used in advanced mining applications such as geometallurgy for estimating rock physical and mineral properties. Thank you for listening to my video. Feel free to contact us if you need some more information on this. Enjoy the conference.